In this video, we're going to be solving systems of linear equations using a technique called addition, or as some people call it, elimination. This isn't the only technique you can use to solve these equations. We could use graphing or substitution as other methods that would work, but for this video, we're going to be focusing on addition, or what some people call elimination. Let's take a look at example 1. We are looking to find values that would work for x and y in this equation, that when we put them in here, they would work also for that equation. So again, lots of different techniques you can use, but let's focus on addition or elimination. Think back to when we solve regular equations. We talk about linear equations as being balanced and on a scale, where one side of the scale is x minus y and the other side is 11, and those are balanced, meaning this value or weight is the same as this one. We have another equation sitting on another scale. We got 2x plus y is the same as 19. This technique says, let's take these two different scales and put them on one scale. If this is equal to 11 and this is equal to 19, then all of this is the same as all of this. So we could put these guys together and they would still be balanced as long as we put these guys together. So let's just do that. Let's put this stuff together. I'm going to combine like terms on the left side of the scale. So 2x and x is 3x. Now something weird happens with the y's. Do you see it? Negative y plus y means no more y's. They cancel each other out because negative 1 plus 1 is 0 y's. On the other side, we got to put those things together. And 11 and 19 is going to be 30. And then we could solve for x. To get x by itself, we divide by 3, and I know that x is equal to 10. Once you know one variable, we can find the other by going back to either of the first two equations. I'm just going to use this guy here, x minus y equals 11, and putting in the information that we just found. We know that x is equal to 10. So wherever I see an x, I'm just going to put a 10. And then we're going to solve this equation for y. So we're going to minus the 10. Be careful, when that 10 goes away, it's still a negative y over there. And to get y by itself, we would divide by negative 1. And I know y is equal to negative 1. So those two lines cross at the point 10, negative 1. It's a pretty neat technique, but you may be wondering, what happens when these guys don't cancel out? In order for this to work, when we do this first step, one of these variables, either the y's like we did here, or you could do the x's, have to go away, or it doesn't make this something that we can easily solve. Not all of them are going to be set up instantly for us to do this. We're going to have to do a little finagling to get this or the x's to cancel out. Let's look at one of those. Example 2 is kind of messed up from the beginning because nobody's in the right spots. In order for this to work, we have to have the x's lined up, the y's lined up, equal signs lined up, and all of that. This first guy looks good to go. We're going to keep him as 7x plus 2y equals 24. But the second one, I'm going to move this 8x, so we're going to add 8x, over to the other side. That'll help get everybody lined up. So we're going to put 8x plus 2y and then equals 30. That's closer, right? We got our x's here, our y's, our equal signs, and then our numbers. So that's better. But if I go to add these together, these will not cancel out. The y's do not cancel out because 2 plus 2 is 4. So we're going to have to do a little extra work here to make this happen. I'm trying to get one of the variables to disappear. In order to disappear, they need to cancel out. If they're going to cancel out, one has to be positive and one has to be negative, and the coefficients have to be the same numbers. Like 7 and 8's never going to cancel out the way they're written. But if I had a -2 and a +2, that would work. So you see, this guy really needs to be negative. Well, I can fix that. I'm going to just change into a negative. But if I change something in an equation, I have to change everything in that equation. In order to change into a negative, we're going to multiply him by -1. Now, if we multiply by -1, we have to multiply everybody in that equation by -1. So it's going to be -7x, -2y, and -24. And this one I'm not going to need to change because remember, I want one positive and one negative. Now we can add them together. -7x plus 8x is 1x. And -2, +2 cancel out, which is what we were hoping for. And over here, -24 plus 30 is just 6. I know what x is now. Once we know what x is, we can come back to really any of these equations and put in that value for x and solve for y. I'm going to use this first equation of 7x plus 2y equals 24. But instead of x, we're going to swap it out for the value of x, which we just found to be 6. So we're going to have 7 times 6 plus 2y equals 24. 7 times 6 is 42. And now we're going to be solving for y. So I'm going to get y by itself. I'm going to minus the 42 over. And we're going to get 2y equals -18. Divide by our 2. And we know y is -9. Meaning those two lines cross at the point 6, -9. In other words, it means we could plug in 6 for the x and -9 for the y, and that equation would still be balanced. It would work. We could also put in -9 for this y and 6 for this x, and this equation would be balanced. And those are the only values that work in both. There's lots of things that work in the first one. There's lots of things that work in the second one. But those values are the only ones that work in both. Let's try one more. Good news. It looks like everybody's lined up, right? I got x's on top of each other, y's, my equal signs, and my constants over here. That looks great. Next, we got to decide who we're going to be able to cross off. Which variable are we going to be able to eliminate when we add these two equations together? Well, right now, this would be 8, so that wouldn't get rid of the x's. And this would be -7. That's not going to get rid of the y's. So we've got some work to do. I need to decide if I want to do the x's or the y's. And to be honest, it doesn't matter which one. Since the x's are first, I'll pick the x's. Now we've got to think this through. How could we get it to where the x's cancel out? I'm going to have to multiply each equation by something. Remember, the goal is for the value in front of the x, the coefficient in front of the x, to be the same number, but one positive and one negative. So let's think this through. If I multiplied this equation right here by 5, it would make that a 15x. Let's do that and see what we're at. So if I multiply this by 5, I'm going to have 15x minus 10y equals 10. That's only legal if you do it to everybody in that equation. Could I make this other x a -15? So I want the coefficient in front of this x to not be 5. I want it to be -15. Well, 5 times 3 would get me 15. But remember, we need one positive and one negative. So we're going to multiply it by -3. When we multiply by -3, this is going to turn into negative 15x. Now watch your signs here. This is positive 15y equals negative 30. This is going to work because now 15x and negative 15x will cross out. They cancel each other out because they're 0. Let's put the others together. If I combine my like terms with my y's, negative 10 plus 15 gives me 5y. And 10 and negative 30 is negative 20. We could now solve for y. Divide both sides by 5 to get y by itself. And I found that y is equal to negative 4. Once we know one, we can find the other. We're going to go back to pretty much any equation you've seen so far. We could use this one or this one. If you wanted to, you could even use these. I wouldn't use those because the numbers are bigger and it doesn't sound like much fun, but you could. But we're just going to pick one of these and put the value of y in the y spot. So I'm going to take that top one. It was 3x minus 2y equals 2. I picked that one because the numbers are a little smaller, but it really doesn't matter. But instead of y, we're going to put in the value of y, which is negative 4. So here, a negative and a negative is going to make this positive 8. To get x by itself, I need to minus the 8 to the other side. And then divide by my 3. And I've got x equals negative 2. That means these two lines cross at the point negative 2, negative 4.